Participants, please take note to the meeting chat. We're going to release some information there. You need to register to this meeting. So we want to know exactly who and from where has participated this session. Thank you. If you have entered, please click on the link and to register there. Thank you. And we are starting in 2 minutes. And you can communicate, you can ask questions to the meeting chat by text. And we are going to select some of the questions to ask to the panelists after their presentation. So you need to put your questions in the meeting chat. So please pay attention to the meeting chat part. Hector.
HA.
Okay, our last presenter is also here. We would like you
Borja, you can start.
Okay. So welcome everyone to our fourth session of this webinar series about bamboo for construction. In this session 4, we are going to be talking about architectural use of engineered bamboo. In previous sessions, we have been talking about the structural use of bamboo columns. We have also touched upon structural architectural use of bamboo columns. So in this session and in the next session, we are going to be talking about the architectural use and the structural use of engineered bamboo. Today we have with us 3 speakers. The first speaker is Mr. Hao Lin. He is the managing director of Integer Intelligent and Green. It's a company, and he's also the director of the Oval Partnership. Professor Lin Hao. He has a Bachelor's of Architecture at Tsinghua University. He has a master also of architecture from the University of Berkeley in California, a PhD from Cambridge University in the UK, and he is honorary research fellow at the Cultural Development and Creativity Research Institute at Tsinghua University. His research interests focus on sustainable urbanism, community development, passive design, ecotourism, urban regeneration, socio-eco balance in placemaking. Projects under Lin's leadership received many prestigious design awards, including RIBA International Award, WAF Award, WAN Award. His projects include the Taikoo Li in Chengdu, in a very famous commercial area in Chengdu, the in-house Eco Hotel, also the KPMG-CCTF Community Center, the Swire Bamboo Community Center, and the Integer Bamboo House, as well as the Hotel Haitang Bay, very famous area in Hainan. Professor Hao Lin is going to be talking today about the craft of sustainability. So with that, I would like to give him the floor. Professor Dr. Hao, you have the floor.
Okay, thank you, Mr. Penat. Yes, good evening, good afternoon, good morning to everyone. I think I'm a special thanks to the organizer in Bar, particularly, inviting me to have this talk. I guess I have 20 minutes to 30 minutes. I don't know. Yeah, I
30,
even don't
30
know.
minutes.
Yes, 30 minutes. That's great. I even don't know who are sitting there. That's a problem of the VC. I think yes. I guess we all believe that the bamboo gave us a unique opportunity and a challenge to rethink sustainability. And however, we all know to achieve better value in bamboo construction is never easy. Because we have been passing all these difficulties. Yeah. So the building and the property industry here, for example, in Asia, in China, in Hong Kong, are very complex, very complicated, and with a very wide range of stakeholder and high level of structure inertia. So that to engineer the changes, I think it's very necessary to involve as many of these stakeholders as possible in a win-win and low-risk program of applied innovation. So I think this is what we offer at Integer, and I think this is definitely a strategy we adopt every day to move things forward, and particularly in the case of bamboo action research we are going to talk about today. So this method, as given in the topic, we call that the craft of sustainability. Okay, so I think we all know bamboo perhaps is an ultimate sustainable building material. It's a grass. It's not a tree. It's a grass. It grows very, very fast, and perhaps maybe as fast as 1 meter per day in the rainy season. And meanwhile, at this same time, it absorbs the carbon dioxide during its lifetime. So it's a very sustainable material. It's easily available, and very available in fair provinces in southern China. And bamboo, like timber, and it can be sustainably harvested. It benefits the biodiversity and the erosion control. And particularly, we want to say, in the sense of the circular economy, it also provides the employment, particularly in the rural area, to the local community. Yeah. So, but if you look at the history, maybe the past 20 years, and China actually has started to produce and export the bamboo plywood to the States. The bamboo ply material has been used to build the high quality civil engineering reinforced concrete. And China, actually, I think in Spain, most of people probably know the Baraja terminal. Yeah, if you look at that soffit, the airport ceiling, that veneer, it's bamboo. It actually was imported from China as early as 20 years ago. Nowadays, I think we saw more and more studies and build projects using the bamboo composites material. And I think through our practice, at least we more and more understand that good research and development, good management are very important for any bamboo constructions. So here we are trying to say, to compete with the conventional structure materials such as concrete and such as steel, including the timber, I think a few aspects such as cost, such as safety, such as durability, and the building codes needs to be well addressed.
Hello, Shi.
Yes.
Sorry, I disturb. The slide seems did not move on.
All right.
Yes,
I think it's start there, but I'm talking about this page. Sorry, this is the second page. Yes.
Okay.
So I'm just talking about the bamboo as one of the most sustainable material. So I'm talking about how to compete with the concrete and steel. And because China and most of the manufacturers, they use bamboo, and it's more than 100 species currently used to manufacture the furniture, artifacts, and all these bamboo plies. Yeah, so the final strength of the material depends on the identifying the species, depends on the manufacturing process in order to have a suitable bamboo structure use. But the result, I think, will finally lead to a very good bamboo material code. Because you know, in China, current Chinese building codes, does not actually approve the use of a bamboo for structure elements. That's a problem. So however, the authority, at least the Ministry of Construction, is very interested in promoting the use of the bamboo. Now, I think one of the probably the most effective strategy is actually to derive a bamboo building code, perhaps by looking at the timber building code and adjust it to suit the special property of bamboo. Yeah. So talking about the because I try to make a comparative study between the bamboo and the timber composite, and the timber composite, we have been using that for more than 150 years. Yeah? So the laminated beams, the PSL, the OSB, and we are very familiar with all these laminated timber materials. And it's have many advantages that these advantages that is quite similar to the advantages of using bamboo composite. For example, the uniformity, the dimension stability, we can actually produce a relatively large size of the for the bamboo structure. And what is the same for the bamboo? Yeah. So I think today, if we look at our Integer, I think Integer is an open partnership to try to drive and execute sustainable action research projects. And for example, I'm going to introduce a KPMG and Swire Property Bamboo project. They've all received pro bono manpower and resources and financial support from international and domestic green enterprises and research institutions and government agencies through building practice, particularly in housing and community construction. And also, I think in the whole process, we try to create opportunities for example, for the private sector developer wishing to provide more socially and environmentally acceptable schemes, and also for a public planner and local authorities seeking ways of meeting environmental performance improvement target. Yeah. So, but given today's topic is a craft of sustainability, I think over the past experience talking about the bamboo construction, it's actually much more than a narrow carbon accounting terms. The craft of sustainability in the case of bamboo construction means it's not only to innovate, but also to challenge everyday notion of value creation. The value of bamboo construction lies actually in designing and executing meaningful and lasting bamboo projects that embrace the three pillars of sustainable development. Environmentally, if you see this chart, environmentally, it is to marry the placemaking and the environmental agenda. Economically, it is to integrate the day-to-day your green lifestyle and industrial innovation. Socially, which might be more important, is to synergize the inclusiveness and the individual growth. So I'm talking about the bamboo in the position to embrace the three pillars of sustainability. Yeah. So after for our integer, after completing a number of leading sustainable pilot projects, for example, as you may know, the Millennium House at BRE UK and Hong Kong Integer Pavilion in Hong Kong, we actually start to develop 3 bamboo building in China. Yeah, this is the first one, the integer bamboo house. Rather than using the natural bamboo poles, the raw bamboo, we actually focus on the structural use of reconstituted bamboo in the pilot project, because we believe it's very more stable, more consistent, and got a great potential to provide permanent structure and a building system. The result back to 2006 is one of the, I think one of the first multi-story laminated bamboo house in the world, offering affordable and also very eco way of building for township and village crossing China. Yeah, I think talking about the reason, there is a very strong reason why bamboo housing is so crucial. If you look at this a table, yeah, the China's urbanization level, yeah, will increase from current 60% to 70% to 2030. That basically means we need to house more than 220 million new people into the urban and town area, and not mentioning all the new rural village and communities that's going to be built. So I think bamboo construction, particularly the bamboo housing, can actually provide a reasonable answer to the issue of housing in such a path of urbanization in a more sustainable way. Yeah. So this is a chart. You may be familiar more than myself. And this table is a comparison between the reconstituted bamboo, natural timber, and the raw bamboo. I think most of the material physical properties of engineered bamboo are much better than table, if you can see, than timber, if you can see. Well, the raw bamboo property is very impressive, as we all know, but the problem still remains. For the raw bamboo, the problem is much about, I think, the durability, the fire resistant issue, the pest control, the moisture control, if you use the raw bamboo as a structural components. Yeah, so, I mean, for the engineered bamboo, we can treat that, we can boil that, we can carbonize it, we can steam it, we can dry it, we can remove the sugar and starch ingredients out of it. So make it much stronger, much durable for the housing use. Yeah. So this is the floor plan of our one of the first pilot studies, the bamboo house. You can see the very tiny dots in this drawing. It's actually laminated bamboo. So we made use of the latest technology to produce the reconstituted bamboo poles of 2 by 4, 2 inches by 4 inches sections to build the demonstration bamboo house. I think this construction is not quite new. The material is very new, but the construction, talking about the type, is a typical balloon structure, or if some people call that platform frame. Very common in Japan, in Australia, and in Northern America. So researchers, we actually work with the researchers at the Kunming University of Science and Technologies, testing this reconstituted bamboo sample, yeah, such as, for example, the tension, the compression, and the buckling, actually. Yeah, so back to 2006, the engineers already sized the structural members of this house and designed the connections based on the, in this particular case, based on the Canadian codes of practice for timber housing. So you see, we actually borrow the timber building codes in Canadian, in Canada, yeah? And actually the house has a bamboo ring screen cladding system with very typical tongue and grooved bamboo panels. And this is the second floor. And this is a
Dr. Hao.
Yes, hello.
Yes, you have 5 minutes remaining.
All right, that's good. Yeah, so I must be very quick. So this showing we are working with a local institute to test the bamboo. And this is the bamboo structure before any fitting out. So you can see clearly the bamboo, the 2x4 bamboo structure. And this is the bamboo ring screen, and it's already finished. It has been standing there for 20 years already. So basically no problem at all. Yeah. And we actually will also use the reconstituted bamboo for the furniture. And the second project, I must run this very quickly, is the KPMG Community Center, working with KPMG, the CSR program, and also the China Children Teenager Foundation. And this is also a very interesting bamboo project. And this is the impression. And we use a post and beam reconstituted bamboo construction. But this time is much with much large the span, more than 12 meters. And we also use a laminated bamboo for the building envelope and the floor finish. Yeah. So we can see that in the quite remote rural area as a earthquake relief project, the charity project. And you can see that all the passive, I'm not going to address this, all the passive design strategy. So very interesting contrast between the bamboo construction and at the background, the generic concrete construction. And finally, it's a tall and graceful curving single bamboo story structure. Yeah. And you can see this bamboo structure inside. Yeah? And also the straw fiber OSB board as a walling and the roofing system. And that one is a solar tube to introduce more daylighting. So I ran these slides very quickly. So everything was made locally, yeah, to employ many people and let them learn all the skills using bamboo. This is before they finish the beautiful bamboo structure. And this time we work with the Japanese because the local Chinese were not very familiar with bamboo construction. So we work with the Japanese very closely to teach the local people how to construct the bamboo construction as a rural area. And it seems that people are very happy with this building. So the third project, run that very quickly, is working with the Swire property. It's again a bamboo structure. So this is a very poor condition of the bamboo making factories locally. So we have to transform that. The idea is to use a bamboo structure to build a home for all. Yeah. So education, industry activities, and community building. Yes, this is a very initial sketch. Talking about bamboo, again, reconstituted the bamboo, and the bamboo structure this time was designed quite like a tree structure, as you can see this construction process. 3 buildings together to form a community building. And this is the finished, to give people very strong sense of the place. I quickly go through this. Yeah. So what I'm trying to say is that over the past 15 years practicing bamboo, we deeply understand that the shift from current business as usual to something more sustainable actually involves the moral and political decision, as well as the incremental improvement of knowledge design, cultural design, and social design of bamboo construction. Yeah. So this is one of the last slides. I'm trying to say, yes, our work will be continued, and there are more researches we need to do regarding the structure property and the durability, construction process, the bioclimate design, and the embodied energy of bamboo construction. So last, but not least, what I'm trying to say in this very short talk is back to the 3 pillars of sustainability, the craft of sustainability, is that any modern bamboo construction, we need to embrace the imaginative, innovative, and inclusive sustainability. And the movement forward demands a fresh framework and also more participatory participatory process. I think that's all about my talk. Thank you very much.
Thank you very much, Dr. House. I can't agree more with you. Thank you very much for your very comprehensive and very useful presentation. You have touched some interesting points, some of regarding the durability of bamboo, the costs, and the ways forward to make bamboo a more competitive material in comparison with concrete and other materials. You have also touched about the use of bamboo housing in urbanization and also the new innovative approaches, the need for more sustainable ways of using bamboo and applying the new the treatments and also the new ways of applying innovative bamboo structures, which I think you have shown a few pictures there which are also very, very useful of how bamboo is being used in China, and I think it's an example for many around the world. So thank you very much for that.
Thank you.
And with that, I want to give the floor to Mauricio. Mauricio has asked me to let him introduce the next speaker, so I pass on to him.
Thank you, Borja.
No problem.
Thank you, Dr. Haolin. In fact, we are receiving lots of questions for you that we'll talk about that later. So you have inspired a lot of people. Thank you very much. Yes, I'm really pleased to introduce Martin Tam, since I know him and I have had the chance to even visit some of his projects in Hong Kong. Martin Tam is a practicing architect with strong architectonic bias of over 50 years of experience. He specializes in project development, administration, and construction management of almost all building types to satisfaction of end users and well as all concerned. Martin is the founder and CEO of Able Mart Limited, based in Hong Kong, and he's the chairman of the Bamboo Industry Committee of Federation of Hong Kong Industries, of course, based in Hong Kong. I consider Martin a bamboo ambassador, and he's, since he's a lot of experience and very passionate about it. So please welcome Martin Tam.
Thank you. Can anyone hear me? Can everyone hear me?
Yes.
Good. Thank you. Thank you for your kind words, Mauricio. Let me jump straight into this. I'm looking at bamboo for the 21st century. We're already 20 years into the 20th century. We have a lot to catch up. We have 80 years to catch up. I won't see the end of day, but I hope bamboo will take center stage very soon. We want to talk about the past in order that we can know the present and what we must do in the future via the bamboo material, a very organic material, a grass, like Haolin was saying, very much part of Mother Earth. We want to straddle the past, the present, into the future. It's about utopian values. In Chinese, we call it 大同. What must we do? We are gone. The 20th century is gone past us for 20 years now. It's a pity that too many people, over 99% of the people are still holding on to the 20th century. But we should be looking into the 22nd century so that we can prepare ourselves better for our children and grandchildren. In Lima, 2014, in the World Sustainability Conference, bamboo is a strategic resource against climate change. 40 countries signed onto it then. Many on this annual event. In 2015, the COP21, Conference of Parties under the United Nations for Climate Change Convention. It signed a lot of stuff. Keeping the temperature rise. Like Howlin was saying, bamboo pumps into the atmosphere a lot more oxygen, about 35% more oxygen than the average tree. Because even the bamboo poles are filled with chlorophyll. The dawning of the bamboo age continues under the UN General Assembly. It's still very new material, and the UNESCO has decided on the 17 SDGs. I believe, apart from number 5, gender equality, and number 14, life below water, bamboo can achieve the rest of the 15 out of the 17 SDG goals. Bring people out of poverty, zero hunger, all the way to partnership for the goals. Peace, justice, etc. All right, 15 of the 17 goals easily achievable. Now we're back to nature, back to Mother Earth. In the face of Father Time, we must do something. How do we carry on generation to generation? Okay, time to grow bamboo. This is a project site that I've recently been engaged with. It is next to the tallest hill in Hong Kong, about 3,000 square feet. This one is about 2,500. The top belongs to the government, but all around, by the way, this picture is taken by a drone 360. So the right-hand side actually connects to the left-hand side. I'm trying to grow some bamboo along the hillsides to make the atmosphere better. More oxygen, less CO2. People will become healthier. On top of that, I'm trying to engage one of the local universities to work with GBA, the Greater Bay Area, to check on the quality, the air quality, not just oxygen and CO2, but the nitrous oxides and the other impurities or constituents of the collective composition we call air. Okay, I'm working with the Guangzhou University on about 20 major species that are abundant in the Pearl River area, Pearl River Delta area, Guangzhou, Southern Chinese. There are, of course, more species than 20, but these are the more prominent that can easily grow in Hong Kong. Okay, I've already grown some of these bamboo, all 20 of them, in the Hang Seng University. A two-year-old university, private university in Hong Kong. So I have the different aspects, different species marked on the trees, so that the children, the youngsters, the university students will know about the species. People will need to be educated, more educated about bamboo. They have to know the species. City folks in Hong Kong have no clue about bamboo. No idea at all. Okay, bamboo is a truly unique non-timber forest resource. I'm flipping through because these are the bamboo architecture that architects around the world has done. But technically, we are also equal to the job about the compressive strength, the Yanka hardness test, the ultimate tensile strength, and how it compares with other materials. Modulus of rupture, comparison, modulus of elasticity compared with other materials. In general, bamboo is stronger in the bending length, etc., etc. The production side. How do we do all these things? 12 steps. 12 steps in the bamboo production manufacturing process. The crux is, of course, to take away the glucose in the timber cells. In the left-hand side, you've got the section of the cellulose inside the timber tissues, the bamboo tissues, sorry. And we extract the sugar to prevent insects and pests. And we use this horizontally, vertically, etc. And we even have carbonized, we can carbonize the color to a certain extent, bamboo. You identify the bamboo by the knots. We need proper management. And we need joints. Okay? This is the most common place in Hong Kong, bamboo scaffolding, all the way to various, so much different shapes and sizes and paraboloids and squares and okay, I'm just flipping over. And this is Mauricio's baby. Very successful design. You should visit his website to see this. I've been there and very impressed. And then at the very same venue, almost, they have varying shades of tested bamboo. And we also have international students competition, doing what they think. Bamboo is for the children. They're whipping us. They're pressing us to do something, to get away from the 20th century. Some of these projects we already know from previous seminars. In Chile, bridges. This is from another friend of mine. It's a gym in the north of Thailand, Chiang Mai. They even have the budget, very low budget. In 2016, they have the Bamboo Biennale International, where different architects from all over, right? Japanese, And in 2015, Expo Milano, the Chinese pavilion, in Beijing suburb, the Japanese architect. And very simple, housing, affordable housing, low-cost housing, bamboo micro housing. In Yangzhou, and what they call a passive housing as a facade screening the sun. Spa resorts in Vietnam, restaurants. Look at the shadow, beautiful. And this is an attempt with bamboo housing. The crux is, of course, to bring the fireproofing materials to be researched, to bring the fire brigade on side. And of course, bamboo is very strong in triangulations. Low energy and bamboo house, again screening from the sun with bamboo screens. And they even make a bamboo school in very poor areas in Bangladesh, Costa Rica. This is in China, a bamboo bridge in southern China, one of the resort hotels. And this is the 2010 Indian Pavilion, 2010 Spanish Pavilion in the 2010 Expo, Shanghai Expo, the Vietnamese Pavilion. And this is a hotel in Thailand, entirely made out of bamboo. And this is our in-bar design competition between our Federation of Hong Kong Industries together with in-bar to hold a competition at the Shanghai Expo. This is some of the winning designs. And this is a school in Bali by another good friend of mine. And people have been asking for these things. And this is the project I built with the then Christoph, who was then with the Chinese University of Hong Kong. This is a simple paraboloid. It is an outdoor pavilion. Too bad the government didn't think it is a long-lasting material. So they asked for it to be pulled down in less than a year.
Dear Martin, you have a few minutes left, a couple of minutes left.
Okay, thank you. Yeah.
It's okay.
All right. Okay, I like to, this is the university, the inside of the university. We got a lot of awards for it. Okay, I like to talk about, this is the project, the latest airport in Israel, southern Israel. This is the Madrid airport. Now I have to go to, oh, I love this one. This is, again, our good friend, Simon Velez, the cathedral. Okay, I will skip the products. Bamboo is our future for humankind. It can save our world for greater humanity. Now, this is the project I want to talk to you about. This is an all bamboo design. Bamboo tubes. This one is 4 meter diameter. they can now produce up to 8-meter diameters. And we just put on some PV on top, warped PV panels. The structure, it is supported by a triangulation support of poles held together by 3D printed connectors. Yeah. Okay. This is for residential housing, and it has components. It is made up of tubes. It is made up of flats. It is made up of connectors. And it has openings to give the breeze, the drafts. All right, this is the components, the bamboo components. And this is the inside. You can make a room out of it. You can make a living room. You can make a bedroom. You can make it whatever it is. It can stand on the hillsides. It can stand in the center of the city. A prototype. And this is the prototype. You can make it longer. You can make it shorter. So the bamboo age is already here with us. Well, 10 bullet points that governments must change to embrace bamboo. 10 bullet points to enable bamboo to take over center stage. There is an urgent call by younger generations to whip us. And of course, we are all specialists, but we are also generalists, what we call ourselves versatilists, to make sure. And of course, versatilist, we must embrace circular economy. We make things, we take things, we make things, we use things, and we recover things. This is the circular economy that was pinpointed, highlighted in the World Green Building Conference 3 weeks ago in Sweden. Again, repeat it again. This is a circular economy. And we need basic standards to get our international trading, the products to be traded internationally. So we need standards, which INBA is doing. And this is the Greater Bay Area, and with which Hong Kong, the purple part, will be working in this part of the world with the rest of the communities. Where there's a red star, this is the predominant bamboo producing area in this small vicinity. INBA has a spot, exhibition spot there. Okay, so bamboo is nature's gift to greater humanity. We must manage it better. Thank you. Sorry for taking your time.
Thank you, Martin. Amazing. You have so much knowledge and experience. In fact, we gave you such a short time, but it's interesting because this will open a lot of people's minds, and people will have to start their own research and studies. So this was an amazing appetizer. Thank you so much, Martin.
No, I think you see with the project, I'm beginning to produce my version of the bamboo language. We've seen too much, like how Lin was saying, we've seen too much trying to emulate steel and timber, but bamboo must have its own language to beat the steel and the wood. Yeah.
Martin,
thank you.
Martin, please stay with us because there are several questions for you at the end of the Hector's presentation, okay?
Sure, thank you.
Borja, please, can you give the word to you?
Thank you very much, Mr. Martin. Very, very nice presentation. I'm impressed by some of the pictures you have shown us. And also, well, I have. It's the first time I've seen the cathedral by Simon Velez. It was really impressive to see it. Also, I want to just mention one thing that Martin mentioned at the beginning, when he was talking about the Sustainable Development Goals. I think also bamboo can contribute also to gender equality if you think it from an economic perspective point of view. We have some examples in Africa from a woman, Gloria, who attended an INBAR training course in 2001, and after that she said that it was like an eye-opening experience, and then she opened her own business, and she has been training a lot of farmers and a lot of people to make some income and livelihood. So I think in that way also, if you think in the economic opportunity, it can also contribute to gender equality. That's just one point that I wanted to raise. I'm sure he will also agree on that. So let me introduce just then our next speaker, Hector Archila. Hector is gonna drive us through a very interesting learning experience about how to make the business case for engineered bamboo products. Hector Archila, he is a senior lecturer of the University of West England in Bristol in the UK. And also he's the founder of Amphibia-based and UK technology-based company leading the development of commercially sound engineered building products using bamboo as the primary material. He is also a professional architect, researcher, and entrepreneur with an industrial and scholar background in architecture, material science, and structural engineer, a long-standing interest in the use of renewable materials in construction. He participates actively in scientific advisory and standardization committees, such as the ISO technical committees, and also he's member of the INBAR task force on bamboo construction. So let him, I give him the floor to let us go through his interesting presentation. Hector, you have the floor. Hector? I think we lost him. Hector, are you there? He's ready with the presentation, but I cannot hear him. Hector, please go ahead. I think you have to unmute your microphone. Hector?
Okay, can you hear me now?
Yes, now we can hear you. Okay, go ahead, Hector.
Excellent. Thank you very much. Well, it's a great place to start because Martin and Howlin have done a very good introduction of all those amazing benefits of using bamboo, all those projects that we have been seeing coming up on bamboo. So let me, as Borja said, let me take you through a little bit of my journey in from sort of research and business and making that, trying to make that case, that business case for engineered bamboo products. Thank you very much for the introduction, Borja, and thanks for the invitation. Right, so let me just start by saying, if this works, yes. So yeah, we heard so far all of that potential of bamboo as a construction material. And I think it's undeniable that bamboo is a wonderful material, grows very fast, has low CO2, produces low CO2 emissions because it sequesters a lot of CO2, is a fast growth material, renewable, has amazing environmental services in land restoration, in water protection, in biodiversity. So that's undeniable. Bamboo is a wonderful material. And of course, we also know, and we've seen many of the projects, and this is a project in which I designed many years ago, and I built in Colombia. This is a large warehouse using a species of bamboo endemic to Colombia called Guadua angustifolia. So there are many other buildings that have been used this material that have pushed the boundaries and that have created a good sort of starting point for bamboo construction and bamboo development. This is another bridge in Colombia, spanning 80 feet in Bogota, designed by Simon Vélez. Another example also, I think Martin showed some of these by Votron in Taiwan. And of course, you might have seen in these cities also examples of houses like these ones, which this in particular is a typhoon and earthquake proof engineer bamboo or bareke house. Bareke with a system that combines cement and bamboo and timber. So it's undeniable. It's undeniable that we have a huge potential with this material to create different types of construction. And all of these examples that I have shown you here are with the round bamboo. But it has also been used as an engineer bamboo, as an engineer product. And engineer products are those products that we take from nature and we transform them into a straight edge product. We transform it, we reconstitute it sometimes as is called. So we shape it to the shape and the use that we need. And in engineer bamboo, we have different types of classifications of or types of engineered bamboo, and this is one that I go with, and I have done before and I have published before. So for me, there are three main types of bamboo: laminated, densified, and fiber boards. And all those different types of bamboo have different properties, but also have different carbon footprint. And this is something also very important with bamboo, and moreover when we want to use it as an engineered bamboo product. And you can see here in this picture how on the left, those ones highlighted, or those ones under these yellow frame, you can see how the engineered bamboo products like the flattened bamboo, ply bamboo, strand woven bamboo for indoor or outdoor use, they have a negative carbon footprint when you compare it to aluminum, steel, or reinforced concrete. You can see the difference on that carbon footprint. They don't sequester CO2, so that's why they have this high carbon footprint. And of course, it takes more energy to produce them. So these engineered bamboo products can be used in different ways, and we have seen many of those examples already, and I'm going to show you just some of them to just start the conversation of what can be done with engineered bamboo. This is an example. The following 3 or 4 examples I'm going to show you are examples in China. This is in the Beijing Design Week. You might remember also the airport, Barajas Airport, that we see it everywhere, with 200,000 square meters of bamboo ceiling. But these are other contemporary examples. This is with using strand woven bamboo, which allows you to use those wavy forms, those very irregular and very sexy structures that the architects love to use. And of course, apart from the benefits of shaping the material to the shape that we want, to the use that we need, We have benefits like the high hardness that we can achieve with engineered bamboo products when we subject bamboo to high processing. We can increase the durability of those products, and some retailers sell bamboo with a guarantee of 30 years. This is only one example of the use of those long-lasting, high durability products in the Netherlands, and this is being provided by a company called Moso Bamboo. So after seeing all of that, and after having heard all what the previous speakers and myself have said, you might ask, why is that bamboo is not a mainstream material for construction then? We have so many examples, we have such a huge potential, we have demonstrated how low carbon, how beneficial it is. So why is it? Why is it that bamboo is not a mainstream material for construction? And in this part of the talk, I'm going to focus more on the engineered side of bamboo products rather than on the round bamboo. I have been involved in different projects for the use of round bamboo, but that's a different and that's another discussion that we are not going to have today. So let me then tell you a little bit more about that. Well, let me actually tell you about the journey, my journey in terms of research and business development, taking bamboo from a round, irregular material, natural material, transforming it into an easier to use material, transforming it into engineered bamboo products that in the future, we hope to use in structural building solutions like it is being done with timber. With timber, we are constructing high-rise buildings of 80 plus meters at the moment. So that's what we are looking at. That's the future. So let's look at some of the problems then. What is it that is stopping bamboo from becoming mainstream? And for me, the first one is the inefficient manufacturing processes that we have. So we have manufacturing processes that waste about or even more than 50% of the material and use about 30% per weight of glue. So 30% of your material is effectively glue in many cases. It doesn't happen in all the different types of materials, but it happens in some materials that are densified. So it is a very wasteful and very energy and labor and labor intensive process. The second one for me is, of course, many of the applications that has been actually mentioned before, is the low added value use of the material. We don't really add much, we don't really use much, we don't really add much value to the products. We have products for different uses, decorative uses, flooring, but not really for structural applications. And then what happens also when we compare prices of commercial bamboo products, engineered bamboo products, with commercially available timber products, you can see this difference. And I'm going to show you a picture, a graph that exemplifies this a little bit better. So bamboo products are non-competitive. You have you have an average of $3,700 per cubic meter. Whilst in materials like CLT, you are looking at something around $600 per cubic meter. But let's look at that in this graph. So we have here on the left, this is CLT. So this is about $600 per cubic meter. And this is using some information from Eastern Canada. And then when you compare with other products, this is a semi-structural cross-laminated product produced by different. Well, this is information that has been collected from different companies, different sources around the world, and I have classified in these three different. In these three different items. So we have something that is semi-structural, something that we could probably use for structures, something that is more for furniture, some products, engineered bamboo products that are more for furniture, and engineered bamboo products that are for flooring and decking applications. But when you compare those prices, and you can see how those prices are really high and not really competitive if we are thinking of making a mainstream use of bamboo. So we have a range between 6 times to almost 20 times the price of a commercial timber product like CLT that is becoming more and more popular nowadays. So we have a problem, and I like to focus on the structural applications, and I like to take you then to how we can make the case for the business case for engineered bamboo products, because there are many problems, of course, but and there is a lot of potential, but we need to look at solutions, at alternative solutions, at feasible solutions. So let me show you what I have done. So the first step, of course, is having an efficient manufacturing system. And what I have been doing has been using a process called densification, which has allows us to streamline the process, to reduce the waste and the glue use of bamboo by 50%, and to lower the CO2 emissions and the energy use. And how densification works is very simple. Well, we are sort of squashing the material, compacting it to the shape that we need for a very short period of time with a set of temperature, pressure, and moisture properties, which we are able to alter and to modify to then obtain some strips, some starting material that is flattened and is ready to be used in different applications. So if we look at the second step, the second solution of what we've been doing is we've been looking at after we densify, after we convert that material into those strips, we laminate it in different fashions, different layouts, which allow us to reduce the irregularities, to spread the defects, and reduce the uncertainty when we are looking at the material, when we are designing with the material in structural terms. So in this case, this was what we did was we glue those strips that we have processed through that first densification process, and it resulted in cross-laminated panels, which we call GX-LAM panels. And the next step of our solution is the combination, because not everything has to be bamboo. And we realized that we were when we were using only bamboo for the assembly of our products, we realized that we were over-engineering the products. So by combining bamboo with other low grade, low value added materials like softwood, that for instance, in the UK, we have species of softwood that grow very quickly. They don't consolidate their tissues very well, so their value is quite low, and they are not really used for structural applications. So by using this type of by making that mix, we are able to develop materials that are more efficient structurally. In this case, we are sorry, I don't know why this is going by itself. We are looking more at increasing the performance over the aesthetics of the material. We don't in this case we don't care about the aesthetics. We do care more about the performance. And I guess that's my 5 minutes. Hello. Okay.
You have 2 more minutes to conclude.
Okay,
about
good.
2-3 minutes.
So let me then show you the results that we have had. The densification has allowed us to reduce the waste of the material and to make a better use of the fiber that bamboo has, to increase the density and make a better use of the fiber. Also, that lamination has allowed us to produce materials with mechanical properties, and this is the modulus of elasticity in compression, which is twice, if we compare a CLT with a cross-laminated bamboo product of 3 layers and 5 layers, those properties have been doubled. So a cross-laminated bamboo product has twice the modulus of elasticity of a CLT product. And then when we look at the price, at the price of those materials, of those products, we can see a gain or a significant reduction of that price. And what we are talking here, and you can see that by using different variations on the layout of the products, we can obtain we can be more competitive with products like CLT. So again, products like CLT with a price per cubic meter of 600. When we compare it to some of the layouts that we have developed, we have products that are that have a reduction of 20% or a little bit, or that are a little bit higher than those CLT products. So combination does work. That combination with CLT, with wood, with low cost, low added value timber, that works, and we keep testing those products. So to conclude, what is next in this journey, as Borja described it at the beginning? There are some challenges, of course, and some further work. And some of you have already, well, some of the previous speakers have already mentioned how important it is to consider the Sustainable Development Goals, to have a circular economy approach, to use more bio-based materials. And I think that there should be a shift on the value that we put on materials, because one of the biggest problems for bamboo, for the mainstream use of bamboo, is economies of scale. Of course, is very difficult to demonstrate a business case when you don't have the capacity to produce large quantities of material. So I am promoting a more localized, so it's somewhere between local and between global and local production of materials, of products, where we can have a more soft approach to the production of our products. Standardization is another challenge, of course, and and we at the Bamboo Construction Task Force in INBAR, we're working in this area, trying to make engineered bamboo products be standardized the same way as engineered wood products are. And of course, something else that we need to consider is, as I said at the beginning, there should be a material mix and a consideration of the cascading, what's happening with the material throughout, or with the products throughout their lifetime, using circular economy approaches to make sure that we have a circular process, and not a take, use, and dispose approach, which is the current approach in our linear economy. And of course, all of this requires investment. We are looking to develop a pilot facility and do more research and development. And I'm going to leave you with this one. We all know that the time is now. We do need to make sure that we act now, and that these type of initiatives are have a place in our new built environment, and in our new normal. Thank you very much. I'll leave you there.
Thank you very much, Hector. Exactly, the time is now, and you are very right on that. Thank you very much for your presentation. Yeah, as you mentioned, the time is now, and we are seeing some movement at the highest levels. As many of you know, recently, about 3 weeks ago, the president of the European Commission, Mrs. von der Leyen, already mentioned the importance of using natural materials like bamboo for construction. But not only for construction, also for other uses that we have discussed in other webinars. But in this case, she specifically mentioned wood and bamboo for construction, which is very important and very relevant. That's why we have to also work on some of these challenges that you are talking about, like reducing loss and reducing waste is very important. I think is making more efficient the bamboo value chain is crucial to have a good comparative advantage to other materials. Also, of course, we have to emphasize more also the qualities of bamboo, and also the potential of bamboo to sequester carbon dioxide and to capture much more carbon than other materials, which not only not capture carbon, but also pollute a lot. So I think we have to keep emphasizing that, which is very important. So thank you very much for that. And yes, the role of bamboo as an HRV solution is crucial. So with that, I would like to pass on to Mauricio for, I think we have some questions for our speakers. Mauricio?
We have many questions actually. Thank you, Hector. It was very interesting, absolutely very interesting. And I think the three presentations altogether give us a very interesting general view and actually detailed view of the architectural use of engineered bamboo. And I will start with some questions. I'll start for a question for Professor Lin Hao from Beni Tanoto from Indonesia. He would like to know, did you also use engineered bamboo for the external cladding? And can you elaborate on the thermal performance or value compared to similar timber cladding, especially since majority of your projects are located on cold climate? Professor Lin Hao, we cannot, okay, great, thank you.
Yes, can you hear me? Yes.
Yeah,
well,
now we can hear you.
Talking about exterior cladding, I think, yes, we use laminated bamboo, and we also use reconstituted bamboo for the exterior cladding. And our experience that is, if you really want to use that for the external cladding, I think somehow you need to cover that. Just in the same way, like you cover some of the timber cladding, yeah? So if you can have a pitch roof, you can have a canopy to cover that, I think it would be much more durable, resisting the bad weather. But actually, two of our projects, the KPMG Bamboo Community Center and the Swire Property Bamboo Community Center, are actually both in a very humid area, and very hot in the summer and a lot of rain in the winter. And actually, if you look carefully about this project, the bamboo house in the Yunnan province actually is without any canopy. But turn to the two later community projects in the Sichuan province, we actually choose to cover the external claddings. I think that's one of the license when using the natural material based cladding for the building. I think talking about the thermal performance is for the Kunming project, the bamboo house. We try to use the cavity wall system. So I think this is more or less a very conventional and a classic construction method. So allow the natural ventilation between the panels, and also allow the ventilation to drive off the humidity and moisture in the cavity wall system. So by having the cavity wall system, by introducing the insulation, for example, in some of the cases, using the newspaper-based insulation, very eco material, we actually try to give a relatively high U value for the bamboo housing. So I would say in terms of the insulation, I would say the bamboo, the performance is more or less similar to the timber cladding. But back to the system, I think the old way of doing the cavity wall and having the insulation inside, allow the ventilation, are still very valid. So I don't know whether I have answered this question or not.
I think it's quite, at least for my concern, I think it's quite clear, and I think it's also important to related to your question. I find your answer. I find interesting that you just not simply talked about the material, but about the system. It's not only a application of a system, but of a ventilated facade. So that will, of course, the material can be great, but if it's not used correctly, then you will, of course, you will not obtain the performances you desire. So I think it's a very complete answer. Thank you very much, Dr. Lin Hao. I have a question from Myanmar to Dr. Martin Tam. It's from Cho Cho Win from the Forest Research Institute from Myanmar. He says that he's very interested concerning with reducing starch. How to reduce the starch, he asks. Which method do you use? And for color, you mentioned that you use carbonization system. I would like to know about the process for carbonization and relationship between color and carbonization.
First question is removing the
reducing starch.
Reducing the starch. I think the proven technology has been to use borax or boric acid. Dip it in the boric acid for a good period of time, and then the sugar is removed. Boric acid or borax. What is the second question again?
Give me 1 second. I was checking for another question.
The color, the carbonization.
The color through the carbonization, exactly.
I think it has to do, I have to check with the manufacturers, but I think it has to do with the temperature at which it is, I think it's more temperature rather than pressure when they glue it together and form it. It has to do with the temperature, I believe. By the way, we have to understand that bamboo the resultant of a bamboo when it is exposed to great heat, the end product is charcoal. Okay. I've been doing an experiment on bamboo doors. Okay, in China, they have a lot of steel doors for fireproofing. In Hong Kong, we have a lot of timber doors for fireproofing. I've had the equivalent thickness of timber and bamboo and just burn it through. And the FRP, the fire resistant characteristic, is much better for bamboo than timber. In actual life, if there is a fire, the worst thing that can happen is for the timber to be some dust on the floor. But with bamboo, it still stands in the form of charcoal. Therefore, it prevents the smoke from coming through. In the event of fires, smoke deaths are much more than burnt deaths. So it is important. I think it is a superlative material than timber when it comes to fireproofing. And of course, a lot more less expensive in terms of, and the environment, in terms of, because it's a natural growing grass. So we do not have to mine the steel for the steel doors, fireproof doors. So I think there was a third question within that batch.
No, there was basically about the carbonization, the color.
Yeah.
Through carbonization and the relationship between color and carbonization. That was basically the.
So if you burn it all the way through, it becomes a black charcoal. So if you burn it to a certain degree, all right, not burnt, but different shades of yellow or dark yellow or something like that. So they actually do apply a little bit of chemical to make sure the color is changed by the heat applied. I have to, generally that is the case.
Yeah, I can see on the screen, I can see Cho Win. I think she's satisfied with your answers.
Thank you.
And now I have a question for Hector. It's a question comes from Pittsburgh, from Kent Harris, professor from Pittsburgh University, bamboo expert. Hector, one of the issues that often arises with laminated materials is the difference in hydrophobicity of the inner and outer wall surfaces of the bamboo. It seems that the densification process may affect this, although it is not immediately clear to me how. Can you comment on the efficacy of the adhesive in this regard? You have to turn your microphone on, Hector. Hector, you have your microphone. Okay. Maybe can somebody unlock Hector's microphone, please? Wait, Jean, can you? Is it you that can activate Hector's microphone? Because he cannot do it by himself.
Okay, we're working on it.
Just one moment.
Yeah, okay. Yeah, it's done now. Thank you.
Okay.
Sorry, Mauricio. Yeah, could you please repeat Ken's question?
Of course. So Kent mentions that one of the issues that often arises with laminated materials is the difference in hydrophobicity of the inner and the outer wall surfaces of the bamboo. It seems that the densification process may, he puts it, he puts comillas, no? He put it on, may affect this, although it is not immediately clear for him how. Can you comment on the efficacy of the adhesive in this regard?
Yeah, very good question. Thanks, Kent. Well, we haven't finished the study of well, we are testing different glues. So we've been working with epoxy resins, with polyurethane resins, and other glues. I do get your point, and I don't know how to reply to that.
Undergoing research, basically.
It is ongoing research, yeah, and we have compared some of the results of the shear strength between different using different materials with different glues. But yeah, we haven't yet set our mind in one particular glue, and we haven't really looked at the effects of the moisture content. Well, in some cases, when you use one of our ideas to work with that hygroscopicity of the two materials was to use a polyurethane resin, which expands with moisture, which reacts in the presence of moisture. So that's something that we have done to sort of counteract a little bit that effect. But yeah, we don't have conclusive results yet.
Well, that's interesting because it's a research undergoing. So it's something that we'll know in the future. We hopefully will have some results for the future, and hopefully we'll be looking forward to have some information about it whenever you and your company will find any results on this. Okay, Hector? It's great. So I will move on. I'll go back to Professor Howe. It's a question it actually comes here from Italy, not far away from Milan. It's from architect Zanetti, Anna Zanetti. She works with bamboo. She has worked with bamboo in Central America, in Costa Rica. And her message is for Dr. Lin Howe. She asks, how do you use bamboo in external stairs?
External stairs.
Yeah, I don't remember seeing external stairs on your projects.
All right. Oh wow. Well, now we have talking about the you know the landscape, right? You know the steps. Yeah. Well, that's very interesting. Actually, I didn't have time to mention that. I think compared with the structural bamboo, I think the bamboo material for outdoor flooring is actually very mature. Now is in most of the cases, basically I think the two trends. One of the trends is use a so-called new wood. Is actually basically to mix the recycled bamboo or timber powder with some of the glue, and to create something quite. I mean, if you touch that, it's quite like a plastic, but it's actually quite a sustainable material. That's very durable material for the outdoor flooring, and it's much available in most of the markets in the world. But I'm more interested in actually in the second trend, which is using the reconstituted bamboo, relatively heavily carbonized. So the color is actually very, very dark. It's quite like a very typical color of chocolate. We have been testing we have been using this bamboo flooring material for basically all these three projects I mentioned. It has been there for many, many years. Basically, no problem, no distortion. Yeah, no cracks. So very durable. But I think definitely just like any of the landscape stair and step, you need a very good structure behind it. If your structure behind it collapses, then no matter how much you build a bamboo on top of it, it's not very decent, right? So I would try to say that there is a great potential to use the bamboo in the outdoor landscape, including the outdoor stepping the stair. Yeah.
That's great. That's
Thank
interesting.
You. Yeah.
In fact, during the Beijing Horticultural Expo, I saw some bamboo products used in landscape. They look very, very nicely, very nice, and resistance, at least during the 6 months of the expo, work perfectly. I suppose they will last longer. And also in a Martin Tam's project in Hong Kong, I was there, invited by the Hang Seng University, and I saw the use of several projects applied by Martin, and also in the exteriors, right, Martin?
Yes, we do it on the exteriors. We do external decking. And I think since we completed it 7 years ago, we are learning, or the Hong Kong people are learning how to manage to protect and preserve. And I think we preserve it very well now. In the first year or two, the manufacturers have it very well preserved, but the Hong Kong users rub and kick and, as if it were a stone. And therefore the preservation technique was too gentle for abuse. Now, 7 years on, we're able to protect them very well with sanding it down and putting thicker and making more coats, so that it is much, much better now.
That's interesting.
We use it very well. Yeah. So, the process of learning to preserve it has come through.
Absolutely.
Very well.
Interesting.
Yes.
That's great, Martin. And I have a question for you, Martin. There's another question for you coming from Philippines. It's Alex de los Reyes, and he's from the University of Santo Tomas from Philippines.
Yes.
And he says, thank you, Dr. Martin. Thank you for that presentation. How would bamboo having its own language help it become a conventional material? Thank you.
The bamboo tissue in itself, in our high school biology days, it is longitudinal. The tissues are much more longitudinal than the timber. And therefore, its movements in one direction is limited. Therefore, it has a very good tensile strength. But it moves. When it absorbs water, it swells much more than the timber. So we have to treat it and seal it to make that timber, make that cell, that bamboo cell, to adapt to its own characteristics. It's a linear, very linear cells, right? Just like the tree leaves. The tree leaves are narrow but long, okay? So we have to respect the nature of the cells, of the bamboo cells as a plant. We need to preserve it. We need to understand it. We need to tailor our technology to this. If you put it in water, it swells and bulges up. Flooring, for example. On the exterior wall, you put it in shingles so that when it moves, it overlaps one another much better, instead of putting it together and then it just breaks up. So to use it, you can look at the backside of my office. It's all timber slats, timber blinds. So respect the material as it is, the raw material. You can use whatever glue that is appropriate. The choice of glue for laminated use of timber has to be very scientific. And we don't have enough research about it, not even the universities, not even the universities.
Right.
So maybe we should consult more on ICBR. They have a lot more technology there next to INBA.
That's interesting. So, but I agree that each material has its own language in a way. So if you want to express the real nature of material, you have to follow its own language, right?
Yes, I think the most important expression of bamboo is the knots. We don't use the knots enough. We just cut off the knots. The knots are very strong. By nature, if the bamboo plant is exposed to windy conditions, they form its own knots. It's a bracing. It's nature's bracing to strengthen the bamboo. And therefore, the strongest part of the bamboo plant would be the knots. Right. I mean, as if in a ship, the rudder in a ship, we should use this as a rudder situation. I mean, wheels, for example, and so on. But we don't use it enough. We don't know the plant enough, not yet.
That's right. We have
I don't know if I've answered my Philippine friends, Alex, well enough, but we've got a lot more to learn about this plant.
Right. Nature is our best teacher, and in this case, it's bamboo.
Yeah.
So now,
to my understanding, ICBR, they have labs, different portions, different sections of different labs to do the physics, the biology, and the chemistry, and the biotoxicity, and the DNA of each part of the plant, the leaves, the leaf tips, the rhizomes, longitudinal section, cross section, lateral section, whatever, of different species of plant. You just bring it over to them and they will have it all analyzed for you. That's my understanding of the function of ICBR. Maybe Jinwei or Kewei can explain more about that one.
Good. Thank you, Martin.
Yeah.
I would like to move on, going to the other part of the world, to Ecuador. There's a question for Hector. It's in Spanish. I'll try to translate it the best as I can. It's from Luis Tulcan Pozo, and it says, Hector, what is missing to make the production of manufactured elements based on bamboo to fly, to go on in the market strongly, especially with elements, structural elements like the sandwich panels? So what are we missing so that these products can become a competitive material in the market?
Thank you for the question. Well, I think that was what my talk was about, wasn't it? Making the case for these engineered bamboo products to be in the market. I think one of the first things that we need to understand is that bamboo has different species of bamboo have different properties, and we need to understand those properties. Of course, it's not the same of as using a tropical species of bamboo like wadua, the one that I've been using on my work, as using mosu, as using mosu bamboo. So the first thing to understand, I guess, that I would say is understand your species. Second, understand what kind of product you are developing. Also, a lot of the time we try and mimic or replace other materials. And one of the problems with bamboo, when you create solid sections, say and that's something that happened to us when we wanted to create those cross-laminated bamboo products. Those cross-laminated bamboo products were very heavy and were over-engineered. And when you compare them to a CLT, the CLT is much lighter, it's much easier to penetrate, to drill through, so the workability is also much better. So yeah, you need to understand what material you're using and what the purpose of what the purpose of all the treatments that you're doing to that material is. And then well, start what we have done with all this experience is we have defined the cost of our processing, and we have varied or we have played with the different layouts, with different variations of the material, with different combinations of the material, and we know where it can be competitive without being a material the same as CLT or the same as glulam or glubam or any other material that is in the market. Is probably, yeah, understanding a little bit more of the properties, what you want to do, and where you want to be, and what you are, what is the competition that you are facing. So many times in this field we become romantic in the use of materials, but I think we need to be a bit more pragmatic and a bit more focused on where, yeah, on what you want to achieve. I don't know if that answers the question.
Yeah, I think it does. I agree with you, Hector. In fact, like for everything, we have to be sometimes poetic, sometimes pragmatic. It's a good equilibrium between both. Only one of these will just lead us to not a special solution. So I think that it's very interesting to look at from your point of view as well.
And I think, Mauricio, I think in construction we use a range of materials. Mm-hmm. Of course, at the moment we might be using too much of one or two materials. Yeah, so I think it's balancing that use of material, that diet of materials, and making it work in environmental, in social, and in economic terms. So it's that balancing act that is the difficult one to achieve.
I agree very much. That's very nice. Well, now I have another question for Professor Hao Lin. It's from Philippines, it's a question from Dulce Punsalan. She asks, which specific European timber standards or ISO are most useful in the development of engineered bamboo standards?
I think I don't know this question. I think we practice in Asia, so we are more familiar with Chinese codes and Hong Kong codes. So I think I think this got to be relatively easy to check out whatever the documents in the European countries. Yeah.
Mauricio.
Yes.
Yeah, there's one question that I think is very interesting. Perhaps it can be for any of the panelists. It's from Gilberto Reyes from South America. It's what's the adequate humidity content in bamboo for construction?
Sorry,
what's the adequate
Sorry?
what is the adequate humidity content in bamboo to be used for construction? The content of humidity.
The water content?
Yes, well,
yes. I think for the structure use bamboo laminated timber, the water content is probably 8 to 12%, and for the reconstituted structural bamboo, which we use, I think the content is normally 8 to 10%. And talking about the raw bamboo pole, I don't know, maybe for the moso bamboo, the water content might be higher than this.
Mm-hmm.
This is the data from our engineering research.
I believe the 10%, the 10% is about right. In the factory, when they produce it, they extract the sugar and the water together. And I think the production, when it comes out, it's still hot and warm, and it's dehydrated to about 10%. Thereafter, it depends on the handling and depends on whether the natural humidity outside is high, and also whether the preservation layer is added on in good time to preserve the dryness. So it's a very tedious manufacturing process.
Yes, and based on the experience of using the timber, I think there shouldn't be any universal standard for the water content. For the water content, we will use the bamboo in a relatively humid climate. Probably you can allow the water content can be slightly higher, because the natural material, the more nature you need to work with the surrounding material in a better way. So it's much about harmonious. That's my understanding.
Yeah, the humidity sometimes it's funny. When 50 years ago, we tried to certify the timber to be 20%, 80% dry and 20% humidity. And in Hong Kong, because of scarcity, when we bring in the timber from Thailand, it's 10%. But they travel in open containers exposed to the sea. When the heavy seas, the waves will whip onto it. And then funnier still is that the fact when it's in Hong Kong, there's not enough land. They just dip it in water in the near coast. So all the drying exercise in Thailand, it becomes futile. One more thing, the previous question about the standard, the timber standard, and so on and so forth. I would suggest that we should refer to the bamboo standard. Bamboo standard by INBA and ICBR have been adopted worldwide, even for trading purposes, as a standard for bamboo. This is well documented. So in the international circle. So I suggest that we look it up when we are serious about trading and so on and so forth. There is the standard adopted by INBA and ICBR as the international standard for bamboo trading. Bamboo
Thank you.
Maybe Kerwei and again Jinwei, they can ratify
build on that. Fantastic. Thank you very much to both of the panelists. Another question which comes from Ecuador, it comes for Hector, but I think any of the speakers can talk a bit about this, because I know that in China also it is being used. So the question says, in spite of the reduction of bamboo waste, do you have experience with projects where this waste has been used? And I think, well, I know in China the waste of bamboo is being used for energy, but I think any of the panelists can give some examples on this.
Bamboo is energy. Bamboo is charcoal, right? In some of the African villages, they have bamboo grown naturally, and what they do is they chop up the bamboo, mix it up with cattle manure, horse manure, and just dry it up in the sun, so that in winter they will be burning this stuff for warmth and for cooking. In itself, I can see nothing going to waste, because bamboo is charcoal. It's carbon, and then when it is burnt, it becomes charcoal. It returns to Mother Earth. So environmentally, there is no wastage. Environmentally, it's much better than, for example, plastics, right?
Yes. So the specific question is whether we have any of you have experience with projects where this waste is being used, and for what purposes? The waste of bamboo. I know in China they use the waste of bamboo for bamboo pellets, for example, or other uses. I don't know if Hector wants to talk about it a bit.
I can talk about the ugliness and the criminal activity of wasting bamboo. In Hong Kong, every building wants to look good. So when they do the scaffolding and when they pull down the scaffolding, it could actually be reused. But every builder, every developer wants a new bamboo. So all the bamboo that has been used is not being reused at all. And they chop it up and just bury it in the landfills, which is criminal in environmental sense.
Yeah, it's true.
Yeah, actually,
there's another question.
There has to be a change of mindset. People have to change their mindset. That's
right. I agree, Martin. There's a question also for Hector. It comes from Xi'an, China. Hector is from Jin Bei, from the University of Architecture and Technology. He asks you, bamboo is a brittle material in tension, but it has certain plasticity in compression. What about engineering bamboo? What are the similarities and differences between it and the bamboo in this respect, and the natural bamboo in this respect?
Yeah, it's a very good question, and I think it comes to something that Professor Ken Harris was commenting on the chat also, and is you can increase that brittle behavior of bamboo by the processing that you do. So you can carbonize the material, and the material will become very, very brittle, and it will break very easily. So I guess what is important with densification processes is to target, to target very well the temperatures that you want to use, and what do you want to, what effect do you want to have in the bamboo. What I've been using the densification for is more to shape the material and to rearrange its fibers, its microstructure into a shape that is easier to use to laminate. So yeah, I think the question goes to, well, the answer goes in that way. Depending on what processing you do, you will have different results. You can have different results on the brittle behavior of bamboo. Something else I wanted to say is, well, what happens also in conventional processing of bamboo, when we transform bamboo into strips, we are removing a lot of the high density material that is at the outside of the cone, because we want a rectangular section. So what we do is we cut and we cut, we sand, and we make it, we make that piece of bamboo a rectangular section. So that's where we are wasting also a lot of the high density fiber material that will be detrimental, of course, to the properties of your final product.
That's great. That's clear. Thank you, Hector. Very nice. I think we've oh, there's a question about, it's a question for all of you. If any of you have experience using laminated bamboo for boat design, or if you know of any case study of a boat designing with a laminated bamboo.
I've seen a couple actually. I've seen people, enthusiasts of these bamboo whirl, using it in boats. Sometimes, sometimes you find the use as only sort of the how you call it, the sheath that covers the hull or the structure of the boat. I'm forgetting the name now, but yeah. Anyway, I've seen. I think if you Google it, you will find different cases in which laminated bamboo has been used for boat construction.
If you agree, Hector, I think probably we can divide it into two, like the interior design, or the bamboo, right? Or the, how do you call it, the shell. I haven't seen shell. I haven't seen a boat, like instead of using other material using bamboo. I've seen interior designs with bamboo, and actually I've seen surfboards. So probably actually it can be used also for the shell, but I haven't seen that yet.
There was one, and I'm just Googling here. I know of an American company called Lambu, which had some use of bamboo. I don't know to what extent they used it if it was in the shell or in the interior. And I think you are correct, Mauricio. In the interior, you can see a lot of the use of bamboo in interiors.
They use it in veneers, bamboo
veneer. Yeah, that's.
I think it's used in a lot of boats, the interiors of boats, but not the boat itself. But it's a decoration. Actually in motor cars also, the dashboards and even the wheel, and also fabric, bamboo fabric in the upholstering of the cars. In the upholstery of the cars. So it's also bamboo, but it's not construction material per se in the traditional sense.
Right.
Speaking of which, Martin, there was also in Japan many years ago, there was I remember reading a paper of a research group using a bamboo mat with resin to build the exterior of the shell of the boat.
Like instead of a glass fiber, like a bamboo weaving.
Yeah,
that's interesting.
Yeah, it's really a trade-off.
Oscar Hidalgo. For everyone, if they don't know about Oscar Hidalgo, it's interesting to look at his book. It's called Bamboo, the God. How is it called?
The Gift of the Gods.
The Gift of the Gods,
yes.
right. In that book, you can see so many different applications of bamboo. Some of them are theoretical, but mostly he did actual practice research and experimenting. So you can check that too. And it's a book that actually I will have to look it back again because it's a lot of interesting researches. We are kind of out of time. We're going to have a last question. It comes from Colombia. I think looking at the name, I think it's from Colombia. And it's a question for Hector. It's from Jorge Montoya. Hector, he asks, Hector, with which wood is bamboo more compatible? With softwoods or hardwoods? And how would it behave with glue? Do you have any experience, Hector, of mixing wood and bamboo or mixed panels? If you were mentioning had some references in your presentation, right?
Yeah, effectively. Well, we are mixing softwood and bamboo, and this version of bamboo, which is a densified version of bamboo, which is almost, it's almost like mixing or gluing a softwood and a hardwood, because of course the bamboo that we have densified has a density of about 900 kilograms per cubic meter, so it's a really high density. But I think is again a very good question, and we need to look at, of course, when you have two different surfaces, the surface that is gonna fail, and you're gluing the surface that is gonna fail is the weakest one. So it is something that you need to consider, and the types of glue that you want to use. It's actually very closely related to the question from Kent, with the wettability and the preparation and the surfaces that you're gluing. Yeah.
Well, that's interesting research. Before saying thank you to everybody, I would like to remind there's a next session. The session number 5 will be the 1st of December. Where now the year is finishing. It's crazy. It's now the 1st of December is next week, and it's very interesting. It's about structural use of engineered bamboo. So we will have Yang Xiao, we'll have Yu Li, Mateo Gutierrez, and Edwin Sea Escamilla. So it's very interesting, very international, a lot of experience from China, from Colombia, and Switzerland, and so I think will be very, very interesting, and hopefully you won't miss it, because all of the sessions are very well designed and thought in order that they are part of a big puzzle. So looking forward to see you next week, and probably somebody from Inbar like Luke Away will like to say some
okay. Thanks to all the speakers we invited. Thanks for all my colleagues to help us to organize such and good activity. So next week we have the last session. We will continue to discuss the engineered bamboo for structural uses. So it's time for Jingwei to group photo now. Please open your video.
Please open your video, and I want to announce that the quiz for our 5 sessions will be provided at the end of the session 5. So we are not providing them after this session. We are providing them at the end, at the closing of the 5th session. Okay, please notice this. So the quiz is those who answers the quiz and feedback to us we are going to provide a certificate for this seminar. Yeah, and the quiz is about all the 5 sessions. So to see your learning. Okay, I'm going to take the shots. Smile.
Say bamboo.
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 Yeah.
Let me go next page.